Welcome back. Today we're going to talk about using categorical data to create charts and graphs and look at what exactly is categorical data and how do we talk about it and how do we create some charts and graphs that are going to help us interpret it. So I'm going to give an example here. Let's say you went to a class and they asked you how are your favorite classes related. For example, if someone who likes art, are they more likely to enjoy science, or are they more likely to enjoy foreign language if they enjoy technology? Where do all these things fit together? And so I'm going to give you a little example here. Let's take some example data here. And let's say you asked a class and you collected some data and it looked something like this. You went down and in the class, 6 people liked art, 9 liked music, 7 liked PE, 4 preferred foreign language, and 4 preferred technology. So we want to talk about things like the individuals and the variables, because those are two very different things. When I ask you a question, you're an individual. The variables are going to be the choices that I give you. And so in this case, the individuals are going to be the students that you asked, and the variables are going to be the favorite electives. Those are favorite electives. So then what we're going to talk about is the variable categorical or quantitative. So maybe you don't know what a categorical variable is, but think about the word quantitative variable. What do you see in there? And hopefully you see the word quantity in there. And so then you need to ask yourself, did the question ask for a quantity? And where students sometimes get confused is, well, you had 6 people that said art, so therefore it's a quantity. No, a quantity would be like, how tall are you? 78 inches. What's your shoe size? Size 12, whatever it happens to be. And so anything you can answer with a number is going to be a quantitative variable. And so in this case, our data is categorical because quantitative could be answered with a number. And so this says go to Stapplet.com and enter the class data and make a bar graph and a pie chart. And we're going to sketch them below. We can actually do that without going to Stapplet, but that would be good practice for you to create data displays. Let's make a little bar graph here for just a second. When we create a bar graph, what we want to do is we want to have our axes represent on the bottom what the categories are, and up the side is the frequency. And so I am going to actually help myself out here, give myself a little box. Something to note is your scale must start at 0. We don't want to start a scale in the middle of something because that's just, that can be deceptive for our data. And on the side here, I'm going to go ahead and add in my tick marks. And on the bottom here, I am going to label this elective, because on the bottom is going to go the categories of the things that I actually asked about. And so right here it's going to be arts. This one's going to be music, then PE, then foreign language, and technology. And as I'm making this chart, something that's really important to remember is that I've got to have a very representative scale, and I want to be able to easily compare the categories of this data by looking at the height of the bars. And so for me, my art had 6, so 1, 2, 3, 4, 5, 6. There's art. Music had 9, so it's up here. PE had 7. Foreign language had 4. And technology had 4. Okay, so that's a way to create a bar graph. Notice bars not connected. Okay, so bar graph here. And I also want to make a pie chart. We're going to talk about a pie chart here. Let's see, let me draw myself a pie chart. There, it gave me a circle. And my pie chart, I'm going to draw my biggest one is music at 9. And then art's going to be here. Technology We're going to have foreign language, and this will be PE down here. Now what you can do is you can shade them different colors, obviously. So if I make, art pink and make music red, I can make PE green. Now obviously my chart is not that scale. So how do we deal with this? Pretty important when you make a pie chart. They're not going to ask you to do pie charts tons because, frankly, drawing them is a little bit problematic. But, however, when you draw a pie chart, here are some things that you're going to want to make sure that you consider. You must include all categories. You must include all categories. Let me make this a little bit neater here. Okay, you must include all categories when you do a pie chart. Okay, and your percent must add up to 100%, obviously, because you are including all of your categories. Okay, so next, bar graphs are really useful. Pie charts kind of useful, but really what we're going to talk a lot about throughout this course is the use of two-way tables. And so what we're going to do is we're going to put in our chart, put in our table here what we have from our chart. So here we go. So this will be more sample data. And let's just say for a second that our data broke down like this. And so now I'm asking you, based on two different categories, what you prefer. So the question is, tally where you belong. So if you liked art, how many of you like math better? How many of you like English better? And so what you'll notice here is that my art adds up to 6. Well, check it out here. I've got a number 6 here. So 6 total art students. The second variable that I'm looking at evaluating them with is, do they like art or do they like math or English better? And so across the way they should be equal. And so here I've got my music, which is 5 and 4. I had 9 total music. I've got 7 total physical education students. That's 7. Foreign language was 4. And technology was also 4. So in this table is represented everyone based on two different variables. So then we start to ask questions like this. What is the percentage of all students who chose PE? Okay, the percentage of all students that chose PE. So I need to know what my total is. So 6 plus 9 is 15. 15 plus 7 is 22. 22 plus 8 would be 30. So there's 30 total students, and 7 of them chose PE. Okay, now that doesn't give me a percent. And so I want to convert that to a percent. So 7 divided by 30, that is about 23%, or equal to 0.233, etc. Oops. So what did I just do here? Anytime we represent decimals that came from a fraction, so like a proportion of the population, we're going to talk about this at length throughout this course. But when you talk about a percent or a decimal, you want to leave the original fraction there and then convert it to a decimal or convert it to a percent. Okay, so the percent of all students who chose math and chose art. So how many students chose math and chose art? So this is evaluating based on two different criteria. So that would be they chose math, so from this column, and they chose art. So right here, 2 of 30 chose math and chose art. Let's convert that to a percent. Divide by 30. Is approximately equal to 0.066. And that's repeating right there. Okay? Number of students who prefer math that chose tech. So this is a little bit different question here. So prefer math that chose tech. So prefer math that chose tech. So you got to look at the bottom first. So They prefer math. So which column is that? So here is I'm going to highlight in pink. Prefer math would be the people from this column here. Okay, so prefer math, there's only 16 people in that column because I've got 2 plus 5 is 7, plus 4 would be 11, plus 5 would be 16. There's 16 people that prefer math. So what is the percent of students that chose tech from that group? Now watch what I do here. I'm actually going to put 4 out of 16, which you know, not 41, just 4, which is equal to 0.25 or 25%. Something really important to do here is you need to not reduce this fraction. So you're going to take it from its unreduced fraction form so that we know how many total students, it's going to be really important to keep track of the total number of students, in this case 16, that chose tech, and then you can convert that to your decimal. Well, there are some labels for these. There's some labels for these numbers, and one of the things I'm going to do here is off to the side, I am going to label them. When I'm looking at an entire column here, and I'm subdividing, well, sorry, when I'm looking at two different things that kind of come together there, this is called the marginal relative frequency. Okay, that's the marginal relative frequency there. When I look at all the students who chose math, so an entire column, and taking a percent as half of the data, right? So math, the entire category out of the whole, that is called a joint relative frequency. Okay, the joint relative frequency. When I look at this at the bottom, this is kind of like a given that. We're going to talk about this later in one of our units, but given that, meaning what was the probability that they were this, given that they chose this other thing, is called a conditional relative frequency. Okay, that's a conditional relative frequency. All right. So now we're going to do a little bit of a breakdown. The way that these notes are going to work is, I'm going to give you a hypothetical data set. We're going to talk through some of the ins and outs and the nuts and bolts of how to look at that data set. And it's going to walk through some steps to get us to the concepts that we're trying to develop for the day. So the first piece of this was taking some data and figuring out, like, what are the two columns? What are we looking at? How do we evaluate some numbers that have to do with that? And now we're going to walk through and start to talk about how do we use this to interpret those numbers. So how many variables does the table represent? Okay, we really have, there are two categorical variables in the table. Okay, there's two categorical variables, and those two categorical variables can be used to predict one another. So which one is used to explain or predict the other variables? So your core class could predict favorite elective. So your core class could predict your favorite elective. And there's a way that these relate that we're going to talk about. Your favorite elective, oops, meant to highlight. Your favorite elective is going to be called, in this case, a response variable. Okay, so that's our response variable. And our core class is going to be called our explanatory variable. Okay. So if we go to Statlet.com, we're going to enter the data. We're going to make a side-by-side bar graph and a segmented bar graph. We're going to sketch them below. I'm going to pause my video here. I'm going to put together those data sets, and then I'm going to come back. It's very, very self-explanatory on Statlet, but I'm going to do that and then bounce right back here with those graphs to show you. Okay, so let's check this out here. You can see that I put my data in here, and so I told you that these lessons are going to develop one another, right? So as we go to start to make some charts and graphs here, we're going to talk about a couple of different types of charts, but the first one that we're going to talk about here is this two-way table. So a two-way table is a chart that puts your explanatory variable on one axis and your response variable on the other. You can see that I labeled those just like our chart in our notes. As we come down the side here and as we go across the top, we're putting in those numbers based on the data, the example data that we had from our problem. Now, what Statlet is going to do, and it's going to be really effective at doing, is creating some charts here. You could create these charts by hand. Obviously, you could. But I want to show you a couple things. First, our chart type is this. It says to make a side-by-side chart, side-by-side bar graph and a segmented bar graph. Let's do the side-by-side first. Our side-by-side is something that you've probably encountered before. It's something that maybe might be a little bit different to you. So I do want to talk about just a couple of things here. Number one, when we've got a side-by-side bar graph here, notice a couple things. It's divided into two pieces here based on our categories of our data. So math and English, they have their separate chunks. Notice I have a dark blue and a dark blue, one for math, one for English. That would be the people who chose art, or so they chose math as their favorite core class, but then chose art as their favorite elective. Over here, the blue represents people who chose English as their favorite core class, but art as their favorite elective. Same for the light blue, that's just music. Orange is PE. Light orange is foreign language. And then there's this green that says technology, but there's no green over here. Why is that? Well, if you remember from our chart, there were no people that chose English as their favorite core class that also chose technology as their favorite elective. And so that's why it's not represented there. Another noteworthy piece of our side-by-side bar graph here. Notice along the side, it is not done by frequency, it's done by percent. Okay, it's not done by frequency, it's done by percent. That's because up here it says relative frequency. And so when we get up to the top, we don't go to 100%. Why not? Well, it would be, you had to add everyone together to get 100%. I could also do it by just straight frequency, where I'd have 0, 1, 2, 3, 4, 5, etc. So that in Statlet you can do that, but also if you're creating your own graph, you can do that as well. That's one data display. Our other data display would be our segmented bar graph. Now check this out. Notice on the side off to the left here, that literally goes to 100%. So the first column represents all of the people that chose math for their favorite core subject. Okay, so they all chose math for their favorite core subject. And then over here for the key, and that's one really important thing when you're drawing charts on the AP exam, you have to include a key. You have to tell them what you're talking about. So everybody that chose math is in this column here, right? And as you go up, the cool thing is that you roll over and it tells you the percent, but you see, you can compare the chunks. So which which dark blue chunk is bigger? Obviously the English. So you'd say, oh, more people who chose English as their favorite core chose art as their favorite elective. And so side-by-side bar graphs are useful for that, and you can pretty easily see which one has the most. Obviously, some of them are a little bit harder than others, like the light blue, which one's bigger. That was 4-3, I think, and so that one's a little bit more challenging. But side-by-side bar graphs allow you to represent 100% of people who answered English said these things. 100% of people said math said these things. Okay. Now, let's bounce back over this way. As we continue to go through, so let's think about these questions here for just a second. How do the bars in the side-by-side bar graph relate to the bars in the segmented bar graph? Well, the side-by-side bar graph just literally gets stacked on top of one another to get that segmented bar graph, right? So as high as the bars are, they get stacked on top of one another. It makes that, they make the different heights and they go up to 100%. So is there an association between favorite core subject and favorite elective? If so, describe it. So let's just think about this for a second. I actually want to bounce on to the next question and kind of ask this in a different way. So if there was not an association between favorite core subject and favorite elective, what would that look like? So if it wasn't true, if it didn't matter if a person said math or English, what would the side-by-side bar graphs look like? Or what would those segmented bar graphs look like? Well, if they're the same, so if there's no association, if it doesn't matter if you like math or English, they like technology the same. It doesn't matter if they picked math or English, they like PE the same. If there is no association, the graphs would look, what do you say? Well, they look like if there's no association. Well, they'd actually look the same. They'd look the same. And if they don't look the same, then there must be some sort of association. There may not be one that you can easily explain or one that you would expect, but if they don't look the same, then there must be some sort of association. Now, let's break it down, the way the notes go. We kind of go through these activities. Sometimes we're going to do those activities in our videos. Sometimes we're not. Sometimes we need the data. Sometimes we don't. Sometimes we need to develop through that sort of process of going through the different activities with maybe some data that you collected or the data that we collected. But always at the end, we're going to have this important ideas box, and we're going to have a sample problem that's from the book that's based on AP type questions and AP type grading. Now, when you start to study and go through your notes, these boxes of important ideas are going to be really, really important, because this kind of distills everything we just did in that activity or in that data set that we just collected and walked through. It's going to distill it into the major principles. So let's talk about it here. Our important ideas. When we talk about categorical data, it reports frequencies and when we talk about frequencies in statistics, it's the counts. So what's the count? Like how many? Or a relative frequency, which is not a count but a percent of the total. And it's going to do that in bar graphs, graphs, or pie charts. Okay, and bar graphs or pie charts. And the other thing that we talked about, I don't even think you realized we were talking about it, but we were. We were actually talking about two-way tables. And these are going to be super important. Two-way tables, being able to look at them, pull out data, pull out conditional data based on if it's this criteria, what percent of the overall is it. They look this way. Outside the table is going to be the totals. So our totals are going to go along the edges down here, and this is going to be our overall total, right? So it's going to be the overall total of the whole thing. And there's those marginal, joint, and relative frequencies that we're talking about, conditional frequencies, go like this. Marginal is going to be something in the B over the total. So one of the totals over the whole thing. So one of the totals from the column here over the total down here, C. A joint frequency is going to be something from inside the table over our total. So one of the specific categories over the total. And our conditional is going to be something from inside over something from one of the columns. So not taking into account the entire total at all, but really just taking into account one sliver of the population, in this case, whatever B happens to be. And so association, association between two variables is defined like this. It's when knowing one affects the other. So you know if a person likes math better as their core subject, it affects the other, meaning you can know something about the other one. All right, so here's a check your understanding. The way you should probably approach these check your understandings is you should spend a little bit of time pausing the video, take some time to go through this, then come back and see the explanation. So I'm just going to keep rolling, but this will be a good time for you to pause, and you can come back and see my explanation as we go through it. So let's check your understanding. Basically, here's what's going on. Students at a local high school were asked which gaming system they preferred, PlayStation 3, Xbox 360, or neither. The graph at right shows the results. Explain why the graph may be misleading. So when you look at this, why might this be misleading? Well, it kind of looks like the PS3 absolutely blows Xbox 360 out of the water. But then when you look a little bit closer, what do you notice? We notice a couple things. Check this out here. Look at our vertical scale. It goes from 44.5 to 49.5. Now, this would be percentage. So 46% of people preferred on Xbox 360. And 49% of people preferred on PS3. Like, the graph makes it seem like they're worlds apart, but really they're not. And this is kind of how data analysis looks like. So you need to consider this when you're looking at charts, when you're out in the world, when you're looking on the internet, those kinds of things, because the charts can sometimes be misleading. So the vertical scale it doesn't even start at 0. And the heights are exaggerated. Okay. The neither group is 0%. And we really don't want pictographs like this. They're sort of deceptive, and it makes it look like the PlayStation 3 is a bunch wider than the Xbox 360. There's a lot of problems with this graph, so you can answer that in a bunch of different ways. Next question is this. An article in the Journal of American Medical Association reports the results of a study designed to see if the herb St. John's wort is effective in treating moderately severe cases of depression. The study involved 338 patients who are being treated for major depression. The subjects were randomly assigned to receive one of three treatments: St. John's wort, Zoloft, which is a prescription drug, or a placebo, an inactive treatment, for an 8-week period. The two-way table summarizes the data from the experiment. So over here, let's take a look just for a second at what's going on here. Let me grab my laser pointer. So at the top is our treatment, right? Our treatment's up here. St. John's wort, Zoloft, and our placebo. The change in depression. So full response, partial response, no response. And then here we have our totals. So something that you could do is you could go through a two-way table like this, and you could put your totals out to the side here, right? So you know your total. Because we do know that in the bottom down here, when we add up everybody, we should have 338, right? But let's kind of go through and see what is going on with our questions here. So what proportion of subjects in the study were randomly assigned to take St. John's wort? Explain why this value makes sense. So I'm going to check out my St. John's wort column, 27, 16, and 70. So that's going to be our total here is going to be 113. And that would be 113 out of 338. Explain why this value makes sense. Well, 113 out of 338 is about a third. So it would make sense. 0.334. It's about 1/3. So if they're doing the study, you want 1/3 of the patients taking each of the three different treatments. Part B, find the distribution of change in depression for the subjects in the study using relative frequencies. So let's peek back up here. Relative frequencies, remember, our relative frequencies are going to be what exactly happens with each of the responses based on the total, okay? And so that part is going to go, I'm going to use a different color, that one's going to go this way. Okay, so our relative frequencies are going to look like this. Full response. And when we do our totals, we have 27 plus 27 plus 37, which would be 91 of 338. Okay, which is about 0.269. Again, leave your fractions in unreduced form, whether you know if they're reduced or not. So leave them in unreduced form. That way we can see the total number of people, not just the decimal. Our second one would be no response. Well, you could have gone partial response next. And that's going to be 70 plus 56 plus 66, which would be 192 out of 338, which represents approximately 0.568. And then our partial response was equal to, and that's going to be our 16 plus 26 plus 13, and that's going to give us 55 out of 338, which as a decimal represents approximately 0.163 of our population. So those are going to be our relative frequencies. All right, let's look at part C. What percent of subjects took Zoloft and showed a full response? So here's my percent of people that took Zoloft, but I'm specifically looking at this 27 number, and 27 is the number of people who took Zoloft and had a full response. But I want to know the percent of that. So that would be 27 out of my 338. That's going to tell me if I take Zoloft, approximately what are my odds of getting a full recovery out of this 338 is what we're evaluating that against, right? So 27 out of 338, which is approximately 0.08%, which is around, sorry, it's approximately 0.08, which is about 8%, okay? That's the basics of categorical variables, guys, and using two-way tables. So hang on to these notes, keep that in the back of your mind, and if you have any questions, let me know. Thanks for watching, and we'll see you next time.